Hello, this is Akshay with another video here, and this video is going to focus on the main applications of heating effect of electric current. Before entering into the main discussion, let me take you back to the main crux of heating effect of electric current. This very effect of electric current states that when the current flows through high resistance wire, yes, these are the important words, high resistance wire, then heat is being generated in that very conductor. As a result of this, the conductor becomes hot. So now the time has come to just look into the main applications of this very effect in our day-to-day life. Let us just go through these applications one by one. There are major three applications I have chosen here. One is number one, that a heating effect of electric current is being utilized in heating devices like electric heater, geyser, oven, water heater, room heater, etc. Electric kettle, you can take it as another example in heating devices. As the name is suggesting, heating devices means those devices which do work under the action of heat. They are gonna make use of heat to carry out their functioning or working. So the working of heating devices exclusively dependent upon the heating effect of electric current. So let us understand that how those heating devices do function by making use of heating effect of electric current. Remember, these devices which I have named a bit earlier, these devices are having high resistance coil, especially made of nichrome. Nichrome is an alloy predominantly made of nickel and chromium. Its resistivity is very high, and hence its resistance is also going to be very high, as we are well aware of the fact that the resistivity of a material is numerically equal to the resistance of a conductor made of that very material, having length is equal to 1 meter and area of cross section 1 meter square. So straight away we will say that the resistivity of nichrome alloy is high, so is the resistance A, and the B, the melting point of nichrome alloy is also very high. Now what happens then? So I have taken, you can say, a kind of a heating element meant for electric iron. In electric iron, there is a heating element made of nichrome. Remember, electric iron is also a heating device. Okay, when the current flows through the conducting wires or cord, then those that very cord or conducting wires are made of copper. Here it is, made of copper, and remember, the resistivity of copper is very low, and hence its resistance is also going to be low. And according to Joule's heating effect of electric current, H is directly proportional to R. Since the cord is made up of copper, there is negligible amount of heat is being generated over there, because resistance of copper is very low, and hence the heat production in copper wires is also going to be low. That's A part. B part, when the same current flows through the heating element made of nichrome alloy, then what happens? The resistivity of nichrome alloy is very high. Resistivity of nichrome alloy is very high. This gives you resistance, and it means resistance is also going to be very high. Then what will it do? When the same current, the current which was earlier flowing through the cord made of copper, doesn't create too much heat, when the same current begins to flow this nichrome alloy, then due to its high resistivity, or in other words you can say due to its high resistance, too much heat is produced in this very heating element. Too much heat. Why? Because according to Joule's heating effect of electric current, we have already understood, and if you haven't just gone through that very video, yes, you need to watch that very video in order to get the clear-cut understanding what the heating effect of electric current is all about. and during the mathematical derivation we have deduced some sort of conclusions over there, and one of the conclusion was that heat produced in a conductor is directly proportional to the resistance of that very conductor. So here it is, as we know that heat produced in the conductor is directly proportional to the resistance of that very conductor. Since the resistance of nichrome alloy is very high, it shows that the heat produced in nichrome, you can say heating element made of nichrome, is also going to be very high. It is too much heat production which makes this nichrome alloy or this nichrome wire or this heating element red hot, and it begins to emit heat radiations, and that's how its working is gonna possible. And second point, its melting point is high. So these are the two factors which are going in favor of these you can say heating elements. That is one, that is yes, its melting point is high, and that is required here because this is working under the action of heating effect of electric current, so it needs to withstand that much heat. It can bear that kind of a heat, and that's why we should know here that its melting point is very high. It shows that when too much heat is gonna produced here, it's not gonna melt away. It doesn't melt away because its melting point is very high, which goes in its favor. So the most important point we learned over here, that the heating devices which I have named before, like electric heater, I have taken electric iron, I have taken over here. Electric heater is there. You can say that is electric kettle is there, electric geyser, electric oven. These are the heating devices. All are having the coils made of nichrome alloy, and then nichrome having high resistivity, so is the resistance high, and according to Joule's heating effect of electric current, if the resistance is high, then the heat production is also gonna be very high. It's so much heat is produced that its temperature shoots up to 900 degrees centigrade, and it begins to emit heat radiation, and that makes the working of these heating devices possible. So remember, that is happening thanks to the heating effect of electric current takes place. And the main point which I have marked in the very opening of this very discussion, that when the current flows through high resistance wire, you have seen that when the current was flowing through these cord, which was the cord which was made up of copper, and copper having low resistance, it means the heat production in copper wire is very low. That was not felt here. We haven't seen the heating effect of electric current in a vibrant way. But when the same current flows through the nichrome alloy or a heating element, it does the wonder there. It generates heat because its resistivity or resistance is very, very high, and that's why heat production is very high, and that makes the working of these heating devices possible. And that is how the, you can say, heating effect of electric current is responsible for the working of heating devices. Number two is the electric bulb. Remember, the electric bulb also works under the action of or under the principle of heating effect of electric current. In electric bulb, there is a tungsten filament present. This is the tungsten which is coiled over there, a thin tungsten filament. Remember, the tungsten has got a very special, has got many special characteristics, and that's why it is well chosen for the job here. It is very important question in board examination, that why do we use tungsten filament in electric bulb. Now it's gonna be the answer of this very question is gonna be in another video here, but let me tell you that is yes, its resistivity, that the tungsten is having very high resistivity. It means that resistivity is high. It shows that its resistance is also going to be high. That's the first point we are going to understand here, that the resistance of this very tungsten is very high. But does it mean? It means when the current flows through this coiled thin tungsten filament, then due to the high resistance, heat generated is also going to be high. resistance is high, so is the heat production. The heat generated is too much high, or you can say that is heat is generated to such a greater level that it acquires the temperature of about 2500 degrees centigrade. A part. Number two is that tungsten must have that kind of a speciality so that it can withstand that heat, so that it should not melt at this very high temperature. And for that matter, another factor goes in favor of tungsten filament is that its melting point is very high. It is 3380 degrees centigrade. That's the melting point of tungsten. That is 3380 degrees centigrade. So much high melting point it has got. And why not so? Because anything which is working under the, you can say, the principle of heating effect of electric current must know to survive under the greater amount of heat production during this very working of heating effect of electric current, that must withstand the high production of heat energy. And thanks to the high melting point tungsten has got, it can survive that heat very well. And that's why in tungsten filament, because of the two parameters we are discussing here, one is its melting point is very high, another one its resistivity is very high, so is the higher resistance, higher the heat production according to the Joule's heating effect of electric current, which states that heat production is directly proportional to the resistance of that very conductor. Higher the resistance tungsten has got, higher the heat production is gonna be there. And the heat production is so much high, you can just imagine that is, yes, such a scale of temperature tungsten got when it heats up and it becomes white hot and begins to emit light. It becomes white hot and emit to give light, and that's how the working of this very tungsten filament or electric bulb is dependent upon the heating effect of electric current. And that heating effect of electric current makes, you can say, makes this bulb to function. And one more point you keep in mind, that is, yes, this is what we are going to learn in a separate kind of a, you can say, a video there. That is why do we choose tungsten as a filament in electric bulb. But let me just take you through, that is, yes, its flexibility is very high, so that it can be just have a coiled structure. Another one is that its rate of evaporation is very low, because there is always danger that it may undergo the process of evaporation thanks to the higher maintenance of temperature in the vicinity of 2500 degrees centigrade. It may evaporate, it may get converted into vaporous form. But one more factor which goes in its favor is that its evaporation or rate of evaporation is very low, which makes it worthy for the job here. And that's why we will say that is tungsten filament or this electric bulb is functioning under the action of heating effect of electric current, thereby generating too much heat thanks to the high resistivity or high resistance it has got. And that heat so generated just emits, you can say, or that heat so generated leads to the, you can say, a spread or a glow of that very bulb. But before entering into the next, you can say, discussion here or next application, let me tell you that this very bulb can just transform the electric, about 95% electric energy into heat energy. Only 5% got converted into light energy. So that's why they are not power efficient, you can say, bulbs there. Anyway, it is not our topic of discussion right now. The main topic of discussion is, which we have discussed before here in this very case, that is, yes, it is also functioning or it is also working under the action of heating effect of electric current. And next one, electric fuse. What is electric fuse? Electric fuse, in fact, a safety device made up of a very thin, high resistance wire, which is made of a special kind of alloy, that is of tin lead alloy. Yes, tin lead alloy. It is 63% there is tin and 37% is lead present, and that alloy is used to make the used to make the fuse wire. Here there is electric fuse for you here. The electric fuse is a safety device having a thin, yes, a thin wire. Thinner the wire, higher the resistance. So is the thinner is the tungsten filament, because we have learned that the resistance is inversely proportional to the area of cross section. Thinner the wire, lower the area of cross section, higher the resistance, and that's what we need here. We need to generate more heat. That's why the resistance is automatically, it has got higher resistance, but by making it thin, we are just adding to the already high resistance of a tungsten filament. More the resistance, more pronounced or more powerful or more overwhelming the heat production will be in that very tungsten filament. And same is here. It is a thin wire made of a special kind of alloy, that is tin lead alloy, having low melting point. Its melting point is low, which breaks, yes, which breaks when which melts and breaks when the current exceeds the safe limit. When the current exceeds the safe limit, when too much current begins to flow through the wires or through the live wire, thanks to the overloading, thanks to the short circuiting happening in that kind of a circuit, under the action of short circuiting or overloading, too much current begins to flow, heavy current begins to flow through the live wire. Remember, fuse is always connected to the live wire. Fuse is always put in series combination, because it is here, it can stop the excessive supply of electric current, and these are the noteworthy points you have to keep in mind. So here, when the excessive current begins to flow more than safe limit, the current is beginning to flow through the live wire. What happens when that heavy current begins to flow through this very wire? Remember, it has got low melting point, and since more current begins to flow, and we have learned in heating effect of electric current that H is directly proportional to I square. Means greater the value of electric current, greater would be the heat production. Since too much current is flowing through this very wire, thanks to the phenomenon of overloading, short circuiting, etc., which may be lethal for the electric installations, electrical devices, and that required to be, you can say, prevented from any kind of a damage. And that's why the name is safety device. It's a kind of a protection or a protective gear for the electric installation or major or other electric devices we have already got in our home. So that's why this is called safety device, because it will save them from any kind of a damage which may otherwise be caused by the excessive amount of electric current. So what is happening then? When excessive heavy amount of electric current begins to flow through this very fuse wire, the fuse wire having low melting point and high resistance, when excessive current begins to flow, then what happens? Heat production is going to be very high. It is so much heat production thanks to the heating effect of electric current. It was so much heat production that due to its low melting point, the wire melts away and breaks the circuit. It melts away. Very quickly it will melt away when the current exceeds the safe limit. It melts away. Why it's melting? Why is it gonna melt? Because of the reason that the heat so produced is enough to melt it away. And where has that heat come from? That heat has come from due to the working of heating effect of electric current in this very wire, because too much electric current flowing through this very fuse wire, higher the amount of electric current flowing, higher the amount of heat production is going to take place there, and that too much heat will melt the fuse wire and breaks the circuit, thereby stopping the supply of deadly or heavy current to the electric appliances, thereby saving them from the excessive flow of electric current. And that's how heating effect of electric current makes the working of electric fuse possible. So there you are. These are the three major, you can say, parameters around which the heating effect of electric current can revolve, or you can say that is these are the three major, you can say, major parameters in which the heating effect of electric current is used. Number one is the heating devices. It is also used in electric bulb, and it is also used in the working of electric fuse. Thanks.